US Physics Olympiad, year 2019, first round, F = MA, exam B. This year exam was split by two flows, exam A and exam B, and the students could participate in any of them. For exam there were, as usual, 24 problems, and that was given 75 minutes for this amount of problems. If you want to get more interesting problems in physics, just subscribe for this channel. Problem number 1. A uniform block of mass 10 kg is released at rest from the top of an incline of length 10 meters and the inclination 30 degrees. The coefficients of static and kinetic friction between the incline and the block are mu static equal 1.15 and mu kinematic equal 1.1. The end of the incline is connected to a frictionless horizontal surface. After a long time, how much energy is dissipated due to friction? Problem number 2. 3 cubical blocks of the same volume are made out of wood, styrofoam, and plastic. When the plastic block is placed in water, half of its volume is submerged. If the wooden block is placed in water with the plastic block on top, the wooden block is just fully submerged. Similarly, if the styrofoam block is placed in oil with the plastic block on top, the styrofoam block is just fully submerged. The density of oil is 0.7 times that of the water. What is the ratio of the density of wood to the density of styrofoam? Problem number 3. Two springs of a spring constant K1 and K2 respectively are connected in series and stretched as shown below. What is the ratio of their potential energies, U1 over U2? Problem number 4. Consider two identical masses that interact only by gravitational attraction to each other. If one mass is fixed in place and the other is released from rest, then the two masses collide in time t. If both masses are released from rest, they collide in time which one? Problem number 5. The density of the Earth increases gradually from around 3 grams per cubic centimeter at the crust to above 13 grams per cubic centimeter at the core. Which one of these plots could show local gravitational acceleration as a function of distance from Earth's center? Problem number 6. A very long cylinder of dust is spinning about its axis with angular velocity omega at steady state. Let r be the distance from the axis. If the dust is only held together by gravity, the density of the dust is proportional to which one? Problem number 7. A trough half filled with water is suspended from wires as shown. The tension is initially the same in each wire. The boat is placed in the trough directly under the left wire. It floats without touching the sides of the trough or overflowing the water. How does the tension in the wires change as a result? Problem number 8. The scale is calibrated so that it gives a correct reading when sitting on the ground. A person holds the scale and presses it on bottom sides with their hands, pushing up on the bottom with the left hand and pushing down on the top with the right. The scale has a mass of 5 kg, and their left hand exerts a force of 200 Newton. The reading of the scale is next one. Problem number 9. A light board of length L is hinged to a vertical wall. A solid ball of weight G and radius R is held between the wall and the board by a force F applied perpendicular at the end of the board, as shown in the figure below. Both the wall and the board are frictionless. The angle between the board and the wall is 60 degrees. What is the magnitude of force F? Problem number 10. A ball of mass small m rolls in a ball bolted on a cart. The ball and cart move together and have a combined mass mc as shown in the figure. Initially the cart moves to the right with the speed v0 with respect to the ground, while the ball is at rest with respect to the cart. The ball then slides down to the bottom of the ball. When it reaches the bottom of the ball, it moves with the velocity vb with respect to the cart. At this instant, how fast is the cart moving with respect to the ground? Problem number 11. Consider a flat uniform square of mass m and the side length L. Cut a circle out of the square that has a diameter equal to the length of the side of the square, with the same center as the square. Determine the moment of inertia of the remaining shape about an axis through the center and perpendicular to the plane of the square. Problem number 12. Two planets A and B have masses ma equal to mb. They orbit a star in circular orbits of radius ra equal 3 rb. Let EI and Li be the kinetic energy and the magnitude of the angular momentum of the planet I, respectively. Which of the following is true? Problem number 13. A water hose is at ground level against the base of a large wall. By aiming the hose at some angle and squirting water at speed v, one wets a region on the wall as shown below. If the speed of the water is doubled, what is the new region that can be wetted? Ignore the effect of water splashing beyond the point of contact. In the answer choices, the dotted line marks the initial wetted region. Problem number 14. A ball is launched at speed v at angle theta above the horizontal toward the vertical wall a distance L away. It bounces elastically off the wall and falls back to its launch point. What was its initial speed? Problem number 15. A mass m equal 100 gram is attached to the end of a string of length r equal 2 meters. A person swings the mass overhead such that their hand travels a circle of radius small r equal 3 centimeters at angular velocity omega equal 10 radians per second ahead of the mass m by an angle of pi over 2. Estimate the force of resistance on the object. Problems 16 and 17. The following information applies to problems 16 and 17. A hoop of radius small r is launched to the right at initial speed v0 at the ground level. As it is launched, it is also spun counterclockwise at angular velocity 3v0 over r. The coefficient of kinetic friction between the ground and the hoop is mu k. Problem number 16. How long does it take the hoop to return to its starting position? Problem number 17. Would the answer to the previous question, namely the amount of time to return to the starting position, be the same for the uniform disk with the same coefficient of friction, launched with the same initial conditions? Problem number 18. Uncertainty in the time for a car to complete a race. The car begins with an initial speed v0 and maintains a constant acceleration a throughout the race. Both v0 and a have independent uncertainties of 10%. Which contributes greater uncertainty to your estimate of the time for a car to complete the race? Problem number 19. A physical pendulum consists of a mass on one end of a massless rigid rod that can pivot about the opposite end, assuming the oscillations have an amplitude of 90 degrees. Which of the following graphs best shows the total acceleration of the mass as a function of the angular position theta measured between the pendulum and the vertical direction? Problem number 20. A block on a ramp is given an initial velocity v0 upward along the ramp. It slides upward for a time tu, traveling some distance, and then slides down for a time td, until it returns to its original position. What is a td in terms of tu? The height of the incline is 0.6 times its length, and the coefficient of kinetic friction between the block and the incline is 0.5. Problem 21. An empty freight car on a level railroad track has a mass big M. A chute above the freight car opens and the grain falls down into the cart at a rate of r, measured in kilograms per second. The grain falls a vertical distance h before hitting the bed of the freight car without bouncing up. How much normal force is exerted on the freight car from the rails at a time t after the grain begins to hit the bed of the car? Assume the grain starts from rest. Problem number 22. The bruise threshold for a fruit is the largest height it can be dropped from rest without bursting. The bruise threshold of a 0.2 kilogram apple on steel is 10 centimeters. Suppose that it always takes 0.1 seconds after impact for the apple to fully stop, and that 4 centimeters square of the apple comes into contact with the surface during the impact. What minimum average pressure is required to cause the apple to burst? Problem number 23. A train travels at 360 kilometers per hour on an almost straight track. The track is slightly sinusoidal, with a vertical amplitude of h over 1 kilometer distance, as shown in a figure. If the maximum tolerable vertical acceleration of the train is set at 0.1 meters per second square, what is the maximum allowable size of h? Problem number 24. A uniform rope of length L and mass M passes over a frictionless pulley and hangs with both ends at equal heights. If one end is pulled down a distance x and the rope is released, the acceleration of that end at this instant will be next one. Problem number 25. A student makes an estimate of the acceleration due to gravity g by dropping a rope from a known height h and measuring the time t it takes to hit the ground. Neglecting a resistance, which one of the following situations will lead to the smallest value of the relative uncertainty dg over g in the estimate?